As I was looking on AliExpress for just general Arduino stuff, as I'm definitely one to do, I came across this PLC expansion board for the Arduino Nano a little while ago, and I just kind of had to see if it was any good or not. And so I got myself one, and I spent a bit of time messing around with it, and ended up writing a library to control it. So this video is just going to be a brief demonstration of that library, and hopefully somebody finds it useful. But before we have a look at the code, I'll just give you a quick overlook of the board itself, and I'm sure there's a pun in there somewhere. So the board has 8 opto-isolated NPN digital inputs here. And these are active low, meaning you get a high when the input is pulled to ground. There's 8 digital NPN outputs here, and these are syncing outputs. There's also 8 analog inputs along this side here. 4 of them are for measuring current, and 4 of them are for measuring voltage. There's also 4 button inputs here, and there's a 4-digit 7-segment display here. And finally, there's an RS485 half duplex transceiver over on this side, which this cable here is connected to. So from this setup here, it was just kind of the expansion board itself that was included. So I had to supply the Nano, the relays, the DIN rail, the power terminals, and the cables, and all that kind of stuff separately, and also this RS485 to USB converter here, which we'll be using in the demonstration. So for the demonstration, I'm going to show you an example from my library, the link to which is down below. And then once you get that loaded up into your Arduino IDE, if you go into examples, you go down to JCT dn24f08 and then go to simple PLC. That's the code that we're going to be working off here. Yeah, so I'm just going to upload this onto the Arduino Nano now, but first I'm going to have to turn on my power supply and plug in my USB. Before we upload it, we have to make sure that this switch here is flipped to the Pro side, where Pro, I assume, is for programming. Once we have our program uploaded, we can move the switch back to the 485 on site so that we're able to use the 485 communication. Right, so let's upload that to the Nano. Okay, so perfect, that's been uploaded to it now. So this is setting up initializing the PLC in general, so that initializes all the pins and all that kind of stuff. But it also sets up the serial communication for the RS485. Here we're just passing in the serial class, and we're setting the baud here. You can set that to what you like, and then we're also setting in start character and the end character. Now I've done a video on parsing. I'll pop a link to that up in one of the corners here. That just means that this is the first character we have to send, and this is the last character we have to send. So then to set the display engine type, we're setting an analog as the display engine, and by display I mean the 7-segment display. So we're setting that to show an analog voltage, and I'm not sure if you can, actually I might just turn off this light. That might make things a bit easier. So yeah, we have the engine that controls the display set to analog, and now we've set it here that we want to display the voltage on V1, which is what this guy over here is connected to. Here I'm setting a gain and offset for V1. I've already calibrated this input so it would show a somewhat accurate voltage, but if you don't have calibration values, you could just not include this line, or you could use the values 1 and 0. And then this sets the analog engine type. This is essentially setting it to a time-based averaging system, where the other one would be readings. You can see all this in the library anyway. So in this case it's time, and we're averaging over 100 milliseconds. So in the background it's taking as many readings as it can in a 100 millisecond period of time. and then showing you the average of that. So that's the value that you're seeing here. So into our main loop, and we have the PLC engine, and its function is to handle the RS485 communication, the analog readings, setting the outputs, the inputs from the buttons, and the information shown on the display as well. The first thing that we're looking at here is we're reading the analog input on V1, and if that happens to be greater than 4.5, then we're setting channel 1 to be true, and channel 1 is the syncing outputs over on this side here. So we've got 8 outputs, and those 8 outputs are connected to 8 relays. So when the output is high, this little light should come on too, signifying that the relay is now closed, but then that is connected to the input here. So channel 1 is connected to input 1, and vice versa for the rest of them. So when we get a voltage of 4.5 or greater than 4.5, we set channel 1 to high, and then that will also set input 1 high. So on this guy here, I've got a device that just lets me set a voltage from 0 to 5. First of all, I'll just show you, we'll set it to 3, and then we'll set it to 4.1. And now we can set that to 4.6. Perfect. So now we can see that there's 2 lights on here, and we've got our 2 lights on here. Why 2? Well, I explained why the first one will be, but then if we come into our code here, we see that if input 1 is turned on, so if you remember, input 1 is connected to output 1, then we also set channel 2. So when input 1 goes high, channel 2 gets set high, and when channel 2 gets set high, input 2 gets set high. So then if we set the voltage then below that, let's put it back down to 4 volts, the both of them turn off. Right, then the next thing we're going to have a look at is the buttons. So what this is here is just checking, has the button been pressed? And if it has been pressed, then we're setting channel 3 to the opposite of what it currently is. So this essentially turns into a toggle for channel 3. So when I press key 1 here, I expect channel 3 to go high, which we do see, and we can also see that input 3 has gone high because it is connected to the output of the relay. So, you know, we can click our way to our heart's content and we'll get the light going on and off. And then finally, then we're looking at the RS485 communication. So what we're checking here to see is the data ready, and the data ready is figured out from, has a message been received with the start character and the end character, and if it has, then data ready is equal to true. But then we're going to do another level of checking here. So we're going to get the characters that are actually in between these 2 characters. And if those characters equal channel 4 on, well, then we're going to set channel 4 to be on. And if they equal channel 4 off, then we're going to set the channel 4 off. So to do this, I'm going to use putty. So I've already got this set up, hopefully. So when I press open, we should get a terminal, and then inside in this terminal, I'm just going to type ch4 underscore on, and then we're going to close that off now. So we should see channel 4 turn on. Right, okay, it didn't turn on because I think I forgot to flip this switch back to RS485 on, which does make sense. Right, so back to our putty, and ch4 underscore on, close it off, and yeah, so we see this light turn on, and this guy here, I'm just going to turn off the button to make that a little bit more clear. So ch4 underscore off. Yeah, okay. That's pretty much it. I mean, this has all the tools you really need to create a simple PLC. So if you found this video useful, like, share, subscribe, and yeah, hopefully I'll get more videos like this out. And if you've got any questions, put them in the comments and I'll definitely try my best to get back to them. And if you've got any ideas, put them in there too, and I'll definitely consider them.